Lesson 10-4, more angles in a circle. Let's begin with a few definitions here. We'll start with the diagram because a picture is worth many words. And so let's start with this angle that we already know, the central angle. That's the guy whose center is in the middle. And then another thing that we kind of know, but we're giving it kind of a new name, this arc that I tried to trace is called an intercepted arc. Oop, D at the end. And then finally, the new idea is an angle whose vertex is on the circle. Inscribed angle. All right, so let's add some words here. An inscribed angle, an angle with a vertex on the circle. And when we say on the circle, we mean the edge of the circle. That's what the definition of a circle is. The center is the center, but the edge is the circle. Intercepted arc. An arc cut off by an angle. There's a fancy word, subtend. I don't think I'm going to worry about that. Cut off means subtend. All right, inscribed polygon. Again, let's go to our diagram here to the right. Inside the circle, we have an inscribed polygon. Remember the chapter on polygon? Seemed like forever ago. And on the outside, we have a circumscribed circle. So this means on the outside, whereas this means on the inside. Scribed means to write. All right. So an inscribed polygon, I'm going to use the word inside, very informally, but a polygon inside a circle, where a circumscribed circle is a circle around a polygon. All right, and now for some math. Yay! This is an example of an angle whose vertex is on the circle. So it's called an inscribed angle. And the measure of that angle relates to this arc that it intercepts. How? It is 1/2 the measure of the arc AB. All right, so let's write that out now in words. The measure of an angle is 1/2 the arc. It, again, looking up at our word, intercepts, subtends the arc. It, not is, intercepts. All right. In theorem 1011, inscribed angles. Notice here we now have two different inscribed angles, here and here. Notice they both capture or intercept the same arc. So those two angles would have to be the same. So no, I guess we were just saying angle ADB is congruent to angle ACB, which will equal 1/2 the measure of AB. All right? So the theorem just says if two inscribed angles intercept the same arc, then the angles are congruent. Ten 12. Well, again, another example. Here we have angle B. Notice the angle is on the circle, so it is inscribed. All right. And then I have another angle here. It too is inscribed because the angle is on the circle. And finally, we have a third angle. It's a triangle. This triangle is inscribed. It has a special feature. One side happens to be the diameter. I'm going to write that. Now it gives me some clues. The clue is this angle, this arc, sorry, that is intercepted by this angle B, okay? Angle B intercepts this arc, and I know that this arc is 180 degrees, then I happen to know something about that angle. Oh, measure of angle ABC is 90 degrees, because AC is a diameter. So angle B is not just any ordinary angle. Angle B is a right angle. Go ahead and make sure you put a right angle symbol in there, which should make the triangle a right triangle. So that's why this is called the inscribed right triangle. So the hypotenuse is a diameter. Look for that in the problems today. They're going to sneak that in. That's what it means to be inscribed in a circle, right triangle, then one of your sides is the diameter and the hypotenuse are the same. And then this is 1013 is a consequence of the former one, because now we don't have a triangle, now we have a four-sided figure. Notice again we have an inscribed, EFGD is inscribed. And notice that means every angle is on the circle. We know that in a quadrilateral, if I add the four angles together, I get 360. That was from the previous chapter. But I'm going to draw a line down a diagonal line. Notice I ended up creating two triangles. And here's the neat thing. If we think about this angle, angle F, and angle D, notice how angle F captures this arc, and then angle D captures this arc. Together, those two arcs add up to 360. Which means these two angles would be half of that. So what's 360 divided by 2? 180. So not only does the opposite D and F, but also the measure of angle E plus the measure of angle G. So we have a property that if you have a quadrilateral that's inscribed, then the opposite angles are, fancy word for adding up to 180, supplementary. All right, and now for some problems. Frequently they're going to give you inscribed angles that reside on the edge of the circle, which we say is on the circle. Then notice measure of angle A captures a 180 degree. Why? Because that's a diameter. So what is 180 divided by 2? 90. Excellent. Measure of angle C. Well, here is C. That captures this arc. I don't know what that arc is. Careful, it's not 7.3. It is, along with this arc, these two arcs would have to also add up to 180. And I see that this is 28. So I'm going to double 28. 28 times 2 is 56. So AC is 56. So now, to get the measure of angle C, I would take 180 minus 56, which I think is 124 degrees. The distance BC. What is the distance all the way across? Well, if I knew half of that, I could double it. I don't. But, ooh, I do know those two sides. So guess what? We can take and square these two numbers and then take the square root of that. Okay? So grabbing the calculator. I have a suspicion we're going to have to take and round our answer. We do. Looks like we get something close to 8. 8.2. Actually 8.3 if I round it properly. And finally, or almost finally I should say, AC is an arc there. We already figured that out. That's 56 degrees because it's 28 times 2. And then the arc AB would be twice the, or I should say, measure of angle C, I forgot to divide this by 2. I just realized we made a mistake. So when I said 180 minus 56, the arc is 124. We have to take n, let me delete my circle, divided by 2, 72 degrees. So the measure of angle C is 72, 8.3, 56, and 124. All right. Going a little bit faster, we're almost done here. 2 pairs of congruent angles. So we see 4 angles that are all what we call inscribed angles. Notice angle B captures that arc. Notice angle C captures that arc. Oh, so that means angle B is congruent to angle C. And then there's one more pair. Do you see them? Angle A captures arc BC, and angle D also captures BC. So angle A is congruent to angle D. And you may want to mark them. All right, find the value of each variable. So again, this is looking at that theorem where we have a quadrilateral inscribed. And so we know that opposite angles will be supplementary. So how do I get the measure of angle B, which is n? Yeah. I take 180 minus 100, because I look to the opposite side, 80 degrees. And the measure of angle A, which is M, is 180 minus 65, 115. All right, good luck in your homework.